Welcome back. In this video, we're going to take care of the camera movement using the MouseLook. So basically moving our character based on the direction our mouse is. And the logic behind camera movement is grabbing the axis of the input and applying that to the rotation of the, well, usually first child object, and one that contains the model and the camera, but not the root, since that's reserved for movement. All right, so even by using the Z rotation, things like leaning becomes a possibility. Let's start implementing that in a MouseLook code. All right, back in our Unity project, let's go ahead and go to the scripts folder inside of our assets. And here you will find a simple camera controller. What we're going to add, however, is our own script. So let's go ahead and call this one MouseLook. Okay, so this script will allow us to look around with our mouse, which is exactly what we want. So now we have to think, what is it that we need? Well, we need to get the input of the mouse, and we need to know the axis. So which direction is it going? Is it going towards the left, towards the right, towards the top, the bottom? So that's something we need to figure out. We need to know how quickly we want to move the player. So we're going to use a mouse sensitivity here, and then we need to transform the player based on that. So we need to make sure that the FPS character's rotation is going to change based on that. So let's get started. First of all, let's set up the update method so that it will get us the axis input of the mouse. So float mouse x, as I'm going to call it, it will be given to us by using the get axis, and here we use the mouse x axis. Okay, so if you recall, if you go to your input manager, you will find the different axes, and the input manager will allow you to modify things. Okay, so here you see the sensitivity is set up already, mouse Y is set up. So here we're going to get the mouse X and mouse Y input. That's the X axis and that's the Y axis. And we get them from the mouse itself. So let's use those. So first of all, we have our X position, and we will also need the Y position. So let's go ahead and add that. It will be called mouse Y, and it will get the mouse Y axis. You need to make sure that you write it exactly this way, otherwise it won't work. So now, as I said earlier, we will need the sensitivity, so the mouse sensitivity. So let's create a public float value mouse sensitivity, pretty long name. I'm going to set that to 100. We can modify it later. And now we can actually use this mouse sensitivity to multiply it to our inputs that we get. Okay, so here, let's multiply that to both of them. And now we need to consider that we have this update method, right? And inside of this update method, we want to make sure that this is going to be frame rate independent. So here, let's multiply with time.delta time, which gives us the time that has passed since the last iteration or the last call of our update method. So let's use that for both of them. Now we need to make sure that we rotate our player, and therefore we need to know what we need to rotate, right? So let's get the player using a public transform here, which will be the player body. Okay, so we're getting the transform component from our player body, which we can then drag in. Okay, so if we save the script, we will then find it, well, once we assign it to something like, for example, our FPS character. So let's actually do that. So here, FPS character, let's drag the MouseLook script in there. And now we need to define what the player body will be. So you see, we can modify the mouse sensitivity and the player body. So now let's drag the root player into it. So the first person player as the body that we want to rotate. All right, now we can use this in order to actually rotate the player, because right now, if we play the game, nothing will happen because we're not doing anything, right? We're not rotating anything. And that's why we can now use this player body to rotate it. Okay, so there is this rotate method that is available inside of the transform class, and we know that our player body is of type transform, so we can now apply a rotation to the object, to the transform. And I'm going to use vector up here, so vector 3 up multiplied with the mouse X value that I have. At this point, we can save the script and let's check it out. Let's see if we can rotate our player at all. So you see, I can rotate the player, but only in one direction, right? I can only rotate him on the horizontal axis. So let's modify our code so that it will work in all directions. Now, in order for this to work properly, we need to consider something that is called clamping, because we want to make sure that the player cannot rotate down infinitely or up infinitely, because this would create a very unpleasant effect for the player. So not the character in our game, but actual player of the game. So let's make sure that we actually clamp the rotation here, because this mouse Y value is cool and all, but it's going to make us sick if we don't clamp it. So if we don't limit it to, let's say, 90 degrees. Okay, so therefore I'm going to need another variable here. I'm going to call this one X rotation, and I'm going to set it to 0. And then I can set it up here inside of my update method. I can just set it to the minus the mouse Y value, like so. And by the way, if you were to add it, you would get inverted control. So maybe it's useful for some type of simulation type games. So this is how you could set it up here, right? Instead of using the minus here, you would use the plus here if you wanted to get it inverted. So you could even have an if-else statement here, checking the settings of the player, for example, and then depending on that, you could then modify, well, run either the minus equal mouse Y or the plus equal mouse Y. All right, now we need to change the position of our current character, and therefore we're going to get the local rotation here by using quaternion.Euler, which returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y-axis. So now here I'm going to pass the x rotation, and for the y and z rotation I'm just going to use 0, like so. So this will only take into consideration this x rotation that we have added. So we call that x rotation, even though it's taking the mouse Y value, because we are impacting the Euler float x value with it. Okay, now let's get into clamping. So let's have a look at what clamping does. So what we want to achieve is that we can only rotate 90 degrees up or down. So rot minus 90 for the x value to go up and 90 to go down. So that's basically what we want to achieve, and therefore we will need to use the concept of clamping. So let's take the x rotation that we have here and let's clamp it. And it's as simple as using the math f struct, which has this clamp method. And what this clamp method needs is, first of all, the input, which is the value, and that's going to be our x rotation, and then the limiting values that you want to use, so the minimum and the maximum values. So in my case, I'm going to say the minimum will be minus 90 and the maximum will be 90 degrees. So that's how we clamp. All right, so now that we have the mouse input, that we have the rotation, and we apply this rotation to the transform towards both directions, we're good to go. So let's run this and see how it's going to look like in our game. And we will notice a little challenge here. Let me show you. It will be very obvious in this case. So here, okay, I can move, and you see my mouse is moving outside of the screen, which is not very pleasant. So it's not very easy to manage this way. Also, the speed is, in my opinion, too slow, but this depends on your mouse settings. So it highly depends on your mouse settings, actually. I'm going to change the mouse sensitivity to, let's say, 1000. And let me run it once again. And now I'm good to go. Okay, so now I can rotate. I cannot move the player yet, but I can at least look around. But now let's fix the problem that our mouse is leaving the game scene, or this game view. In order to fix that, there's one very simple line of code that you can use, and that is cursor dot lock state is equal to cursor lock mode dot locked. Okay, so this cursor locked mode is an enum which has multiple states. It's either locked, let's look at it actually, none, locked, or confined. And in our case, locked is what I want to have. So here, making sure my mouse doesn't leave the game window. All right, let's save the script and let's get back to Unity and let's run it. And now you see I'm locked in the game. My mouse is locked. I can use the escape key in order to get out of it. But once I click into it again, my mouse is locked again. Escape in order to get out of it again, and then stop the execution. Now let's maximize on play. So that's going to look a little better because it's bigger. So there we are. Now I can play my game, and I cannot shoot yet. I can run yet, but we're going to take care of all of that step by step. So see you in the next video.